Okay, last time we were talking about fractions and simplifying them and factoring a number out into primes. So that really is based on multiplication. Let's take a look. If we take our multiplication table is simply a distance times a distance. So, and I'm just going to count the squares. So I have 1 here. Like so. Now there's a couple patterns here that you can look at for your numbers. 2's, everything that is multiple of 2, you have a 2, 4, 6, 8, or a 0 as the last digit. Anything divisible by 5 has either a 5 or a 0 in the last digit. 4 is just 2 times 2, so if you can get a 2 out of it and then get a 2 out of it again, you've got a 4. 3's have a special rule where you add all the digits together and keep doing that until you get down to a single digit. And if that single digit is 3, 6, or 9, then it's divisible by 3. And that covers most of your numbers, because most numbers are going to be divisible by 2, 3, or 5. That eliminates a lot of numbers. And then you have your 11s and your 7s and your other primes that you can't divide. They're not divisible by anything other than themselves. So, for example, I see a 3 here and a 3 here. Those are only places on the thing that I have a 3. I have a 2 here and here. So, and those are the only 2 places those appear by themselves on the multiplication table. My 4's, on the other hand, I have 4's here, here, and here. So I can take my 4 and divide that into 2 and 2. So 4 is not prime. Okay, so my 2's and my 3's are prime because those are the only places those appear. I can either do them this way or this way, but nowhere else. My 5's appear here and here, but nowhere else in that combination. Let's do the 6's. So I have 6. Now if I look at my 6, and I find my 6, I have a 6 here, and I have a 6 here, here, and here. So my 6 is not a prime. That's a 2 and a 3. My 8's, anything I have in here is obviously not a prime. So 6, if I do my 7's, 7 ends up being here and here, but I don't have any 7's between those. So my 7 is a prime. My 8 I have here and here. So 8 is not prime because obviously I have an 8 over here, but I also have 8's in there. I have a 9 in the middle. 10 I have, but I don't have an 11. 8, 9, and 10 are not prime, and my 11 is prime because I don't have an 11. I do have a 12. I don't have a 13. I do have a 14, a 15, a 16, and then I don't have a 17. I have an 18, and so forth. So that allows me to find out what my prime number is. Basically anything in the middle of my multiplication table, these numbers are not prime because I can get that number by multiplying these 2 numbers. And so that allows me to find my primes. Now once I have my primes, I can use those to help factor out and simplify a fraction. Let's pretend for a moment that I have a 12/18, and that's a fraction that I have. Now the 12 and the 8 are both even numbers, so I can know that I can get a 2 out of that. I can divide both of those by 2. So that is going to give me 12 divided by 2 is going to be a 6, and 18 divided by 2 is going to be a 9. Now a 6 and a 9, 3, 6, and 9 are all divisible by 3, so I can get a 3 out of that. Oops. Divide by top and bottom by 3. So 6 divided by 3 is going to be my 2, and my 9 divided by 3 is going to be 3. And now I have a prime number in the top and the bottom positions. Specifically, I have a prime number underneath. Well, okay. So these numbers are both prime. They're not, I can't divide that evenly because that fraction ends up being as simplified as I can get it, because I don't have anything that I can get out of both top and bottom. But by trying my primes first, I can simplify fairly easily.